Welcome back to Dan Smart. In today's video, we are turning up the heat with differentiation rules. From the power rule to the product rule, quotient rule. These tools are your shortcuts to mastering derivatives like a pro. Say goodbye to long limit definitions and hello to quick, efficient calculations. Let us dive in and make differentiation fun and effortless. Now, I want us to consider some properties, right? So for differentiation rules, we have derivative of a constant function. Basically, what that says is whenever you are differentiating a constant, say 8, if we differentiate this, you have to get 0. If we differentiate a constant, say -1, this also goes to 0. So whenever you have a constant and you are differentiating, irrespective of the variable you are differentiating it to, you should get 0. Now the second one says that if you have a constant multiple, that is, for instance, if we have 5x and you're differentiating this, you can bring the constant outside, then you differentiate the variable. So in this case, you have 5, and if we differentiate x, you have 1. So this is 5. Another example is you have, say, -8t. Now you can bring the constant outside, then you find the t of your variable, so t. And in this case, this is also -8. So that is basically the constant multiple rule. Now the power rule says that if n is any real number, then we can have the derivative of x to the power n is equal to this expression. Now this means that if we have 7x cubed and we are differentiating, the 3 will always come down, right? So we can have 7, then remember the x using the constant multiple rule, we have s cubed. So this is just 7, right? Now for s cubed, this 3 is your n. So that one comes down. Then we have x. Then we subtract 1 from the exponent. So in this case, we have 2 right here. So this simplifies to 21x squared. So this is how it works. So if we have 6x to the power -3 and you're differentiating, the -3 comes down to multiply 6. Then you subtract 1 from the exponent. Remember, so this is -4. So you have -18x to the power -4. So we are going to use these differentiation rules to solve some examples. Now, the first example that we are going to consider is we are to differentiate the following. So we have a -6, b s cubed, c x to the power -4/3, d you have x to the exponent of √2, and e is 3s squared. So for our a, we know that when we differentiate a constant, so whenever we differentiate a constant, we get 0. So this goes to 0. For b, if we differentiate s cubed, this is using the power rule. The 3 always comes down. Remember, it is nx n minus 1. So in this case, our n is 3, our x n minus 1, so 3 minus 1. So this is just 3s squared. Let's move on to the third one. So for the third one, we do the same thing, right? N comes down. So in this case, our n is -4/3. Then x, then we subtract 1 from the exponent. So we have this. So this is just -4/3x. And if you do this, you just have -7/3. So this is a derivative. For the part D, you have x to the exponent of √2. So in that case, your exponent, which is your n, always comes down. you have x, then you subtract 1 from the exponent. So you have root 2 minus 1. Remember, you cannot simplify this expression, so you just leave it as it is. For the e, you have 3x squared. So in this case, we are going to use the constant multiple rule and the power rule. We are going to combine them. For the constant multiple rule, we can have the 3 outside, then the x of s squared. Then we have 3, then using the power rule, in this case, our n, which is 2, comes down, x, then we subtract 1 from 2. So we have 3 multiplying 2x, which is just 6s. Okay, so our second example is, we have to find the derivative of the polynomial so our polynomial is y equal to s cubed plus 4/3 s squared minus 5x plus 1. So in this case, we want to find the derivative. So dy dx is equal to d dx. Remember, we have s cubed, then d dx of, or we can simplify it first. So you can have the constant outside, then d dx of s squared minus 5 d dx of x plus d dx of 1. So our dy dx is equal to, using the power rule, n comes down, you subtract 1 from n, so you have 3s squared. For the second term, you have this. So in this case, 2 comes down, you subtract 1 from 2, so you just have x left. In the third one, we have 5, and if you differentiate a variable, just x, remember, if we have x, it has an exponent of 1. So if 1 comes down, we just have 1x, then you subtract 1 from 1, so which is 1 minus 1. So 1 times s is x, 1 minus 1 is 0, and any number raised to the power 0, any alphabet raised to the power 0 is 1. So in this case, we just have 5 multiplying 1. I hope this is clear enough. So we have 1 over here. And if we differentiate a constant, this goes to 0. So we have our dy dx to be equal to 3s squared. Then 4 multiplying 2, we have 8 out of 3x minus 5. So this is our derivative of the polynomial. Let's look at a different question. For question 3, we are asked, does the curve y equal to x to the power of 4 minus 2s squared plus 2 have any horizontal tangent lines? If so, where? So to solve this problem, you have to understand what horizontal tangent line means. Now, horizontal tangent lines, if any, occurs where the slope, so our slope, that we've already established that our slope is y dx. So horizontal tangent lines, if any, occurs where the slope is equal to 0. So in this case, we have to find dy dx. So this is our y. So we have d dx of x to the 4th minus 2d dx of s squared plus d dx of 2. So the y dx in this case, So this we have 4x cubed minus 2. Then over here, if we differentiate, you have just 2x. And if we differentiate a constant, this goes to 0. So if you simplify, you just have 4x cubed minus 4x. So to find the horizontal tangent lines, all that you have to do is to equate this to 0. So you have 4x cubed minus 4x equal to 0. How do you find x? First of all, notice that we have 4x here, we have another 4x here, remember? So we can just factorize 4x out. Then we have x squared minus 1 equal to 0. So having this means that 4x is equal to 0, and also x squared minus 1 is equal to 0. So this basically means that for 4x equal to 0, if you divide through by 4, you have x is equal to 0 over 4, which is just 0. And for x squared minus 1 equal to 0, remember this is difference of two squares. So this is the same as x minus 1, x plus 1 equal to 0. So it means x is equal to 1 or x is equal to minus 1. So the curve y equal to x4 minus 2x squared plus 2 has tangent lines at x equal to minus 1, 0, and 1. So I hope this is clear. So to find this, you just have to set the y over the x equal to 0. Now, let's move on to some important concepts that we should know. That is derivative, product rule. So basically what this says is that if we have two functions, that is f of f and g, and these two functions are differentiable, then their derivative can be written as which in short is fg prime plus f prime of g. So let's quickly use this to solve an example. So we have to find the derivative of a 1 over x squared plus ex. So in this case, we know this is our f and this second term is our g. So we can have f is equal to 1 out of x, but note that 1 out of x is the same as x to the power negative 1. We can also have our g is equal to s squared plus ex. So to use the product rule, we know that f of g prime, if you're finding this is f times the derivative, so the first function f times the derivative of the second function plus the derivative of first function times our second function. So we have to find f prime and g prime. Now f prime, using the power rule, negative 1 comes down, we have x, then we subtract 1 from the exponent, so we have negative 2. Remember, this is also the same as negative 1 out of s squared. For g prime, using the power rule, we have 2x plus, now whenever you differentiate an exponential function, e to the x, you always end up getting the same thing. So e to the x is the same as e to the x. But note, if the exponent changes now to e to the power of 2x, if we differentiate this, first of all, you have to differentiate what is over here, which will give you just 2, then you multiply by this. I hope this is clear enough. So in our question, if we differentiate e to the x, we just have the same thing, which is e to the x. So now let's use this and do our substitution. So fg prime is equal to our f, which was given as 1 over x. Our g prime was given as 2x plus ex, plus our f prime, which is, so our f prime would just be negative 1 out of s squared, multiplying our g, which is just s squared plus ex. So this simplifies to, if we distribute the 1 over x over here, we have 2x over x, which will just give 2, plus we have ex over x. And if we distribute the negative 1 over s squared, we have s squared over s squared, which is just minus 1. Then this is minus ex out of s squared. So if we simplify further, 2 minus 1 will just give you positive 1. Then plus ex out of x minus ex out of s squared. So if you use the product rule, this is what you get. If you use any other formula or any other approach to differentiate, you will still end up getting this. So I hope this is clear, right? Let's look at a different one. So for, let's say b, we have to differentiate y equal to 2g 2x. Now for this, our dy dx is, remember, constant multiple, right? So we can have d dx of our y, which is e2x. In this case, we have 2. Remember, if we differentiate this, you have to differentiate the exponent. So if we differentiate 2x, we have just 2. Then we write this exactly as it is. So now 2 by 2, we have 4 e2x. I hope this is also clear. Now, since we've gotten to know the product rule, let's move on to the quotient rule. So for the quotient rule, basically has to do with fractions. So let's say we have two functions that are differentiable. That is our f of x and our g of x. So you know this is rational form, there is a fraction. Now if we are differentiating this, this is just g of x, f prime of x, minus f of x, g prime of x, out of g squared. So low the high minus high the low over low squared. So let's use this idea also to solve a question. So we have to find the derivative of y equal to t squared minus 1 out of t cubed plus 1. Note that over here we can't use the product rule, right? Because we don't have two terms multiplying. Instead, we have two terms dividing. So the only idea is to use quotient rule. So whenever you have multiplication, you use product rule. When you have division, you use quotient rule. So your f is always your numerator and your g is always your denominator. We have to find f prime. So if we differentiate this, if we differentiate t squared, you're going to get 2t. If we differentiate a constant, that goes to 0. If we differentiate t cubed, we have 3t squared. And if we differentiate 1, that also goes to 0. So let's us use that to substitute into our formula. So we have f over g prime. So this is, first of all, write g. So your g is t cubed plus 1. Now f prime, we had 2t minus our f, which is just t squared minus 1, times g prime, which is 3t squared, out of g squared. Now we know that g is t cubed plus 1 all squared. So the next thing to do is to just expand the parentheses. So 2t times t cubed and 2t times 1, we have 2t to the exponent of 4 plus 2t, then minus. Then we have to expand this also, so we have 3 2 to the 4th minus 3t squared. I hope this is also clear enough. Then we divide by t cubed plus 1 all squared. So f of g all prime, this is 2t4 plus 2t minus 3t4 plus 3t squared out of t cubed plus 1 all squared. So now if we simplify this, we get to see that 2 minus 3, that is negative. So we have minus t4 plus 3t squared plus 2t out of t cubed plus 1 squared. So this will be your answer if you differentiate this. So the common takeaway is whenever you have a division, you have to use the quotient rule. Okay. Let's find, the third question is find the first 4 derivatives of y equal to s cubed minus 3s squared plus 2. So with this question, all that we have to find is just the first 4 derivatives. So we want y prime. Note y prime is just differentiating this once. So in that case, using the power rule, we have 3s squared minus 6x. I hope this is clear enough. For the second derivative, we have to differentiate this term. So using the power rule again, the 2 comes down, you have 6x, then you subtract 1 from 2, so you just have 1. Then minus, if we differentiate 6s, we have 6. For the third derivative, we have, now if we differentiate 6x, you have 6. If we differentiate negative 6, you have 0. And for the fourth derivative, if we differentiate a constant, you get 0. So this is basically the first 4 derivatives of our polynomial. I hope this is clear enough. If you have any question, let me know in the comment section. For question 4, we have to find an equation for the line perpendicular to the tangent line to the curve y equal to s cubed minus 4x plus 1 at the point 2, 1. So in this case, what you have to do is note that the equation of a tangent line, as we know, is y minus y1 equal to mx minus x1, where m is the slope. So first of all, we have to find our slope, which is dy dx. So dy dx is just differentiating this polynomial. So if we differentiate s cubed, you have 3s squared. And if we differentiate negative 4x, you just have negative 4. Okay, so this is our dy dx. But to find the value, we have to replace x with 2, right? So we have, so dy dx is the same as f prime, right? So f prime of 2 is 3 times 2 squared minus 4, which is just 3 times 4 minus 4 which is 12 minus 4 is equal to 8. But remember, the question said the line is perpendicular. Now, because of this, we have to, whenever you have a perpendicular tangent line, then it means that you have to find the negative reciprocal of your slope. So your m is negative 1 out of m. So your new m that you're going to be working out is negative 1 out of m. This is because the line is perpendicular. So in this case, we have negative 1 out of our m, which is 8. So we can write our equation as y minus y1. y1 is 1. Our m is negative 1 out of 8. Then x minus x1, which is just 2. So this implies that, so we can multiply the left-hand side by 8. So we have 8y minus 8. And this is, we distribute the negative 1 on the right-hand side. So we have negative x plus 2. So we can send the negative 8 to the right-hand side. So we have negative x plus 10. So to find y, you just have to divide each term by 8. So you have negative 1 over 8x, then plus 10 out over 8. And 10 over 8 is just 5 out of 4. So I hope you've understood the basic concepts that we did over here. Okay, so great job sticking through the rules of differentiation. Now you are armed with some serious calculus firepower. If you enjoyed this video, give it a thumbs up and let me know your favorite differentiation rule in the comments. Don't forget to hit the subscribe button for more fun and easy to follow calculus lessons here on Danish Math. See you in the next time as we tackle even more exciting math topics. Bye.